Well, hello everybody. Miss Terry's here again today to do a video. This one is going to be on radicals. In this one, I'm going to be adding, subtracting, multiplying, and dividing in this video. So it is a little bit lengthy because it goes over all four operations. So let's begin. Let's look at a few things about the definitions. This was pulled straight from your textbook. So the only time you can add these things is if the radicals match. So you'll see in the first one, the 3x and the 3x match. And in the second one, you have x minus 7 and x plus 4. They don't match. So as long as the inside matches, you can add or subtract them. The steps, you simplify it first. Just because it doesn't look like it matches doesn't mean that it doesn't. And then you add or subtract any like radical expressions by adding or subtracting the coefficients that are in front of the radical and then keeping the radicand the same. That's very important. So you add or subtract the front. So you add or subtract the coefficient and then you keep the radicand the same. Okay, so I took some of these problems here. We have two sets. Two sets are when they will match. Things are pretty simple. And then we have some that are a little harder that they might not match. Okay, so let's try the ones that do match first. Okay, so let's try to keep it colorful. You know I like colors. Alright, so number one. When I look at number one, my 5x and my 5x match, so I'm fine. They do match. Let me see, I'll just put it over here. So I know what's on the inside. Remember, it says keep the radicand the same. And then I take my coefficients and add them. The problem here, just don't forget, you have a coefficient of 1. So 3 plus 1 is 4. Okay, number 2, my underneath is the same, so I add the outside, 9, 10, 11, 12, 13, and then I keep the same. Right, number 3, inside the same, 5 minus 3 is 2, keep the inside. Number 4, 14 minus 5 is 9. Keep the inside. Number 5. It's not going to change if it's cubed. 10 plus 4 gives me 14. And then I keep the inside. Number 6, at this point, should be pretty self-explanatory. That is 2 onto the cube root of 3x. So here's where things get a little tricky in 11, 12, and 13 because the inside doesn't match. So you're thinking, well, I can't add these because they don't match. But you have to remember that the first step told you to simplify. So I'm going to take the first one and simplify it. Square root of 4 is 2. X squared is even, so I pull out half. And that is simplified. So now I have an equation that now looks like this. And you will notice that now my insides match. So the answer to number 11, let's see, 2 minus 3 is negative 1. Watch how I write this though. Just like this. You don't put the 1 in front. It's kind of like not putting the 1 in front of a variable. Okay, number 12. They don't match. So looks like I'm gonna have to do some reduction on both of them. So if I do the 49, square root of 49 is 7. 7 times 5 is 35. My M2, I take half of that and I get M on the outside. I take my N5 down to N4 so I can get an N2, and then I'm left with that last one on the inside. Okay, let's see if I can do the next one. Let's see. Square root of 16 is 4. 4 times 3 is 12. Looks like I have an M there. I split my N5, and I am left with one N. If you didn't understand that, rewind the video. Just went over that. Okay, so now you can see that what's under here matches. Question, you have to remember, can you add like terms? Yes, these are like terms. M, N squared is the same. So I'm allowed to do this one. So I do my, let's see, number 12. 35 minus 12 gives me 23. And that is M N squared onto the square root of N. Okay, I need to get me some space over here so I can do number 13. 13 involves some cubes, so I wanted you to see, getting the cubes with circling your 3 digits, set for 3s. That's why I chose this one to do. And I guess we'll do purple. Alright, so I know they're not simplified, they don't match, so I have to take care of that first. So I have to simplify the cube root of a to the 8. Okay, I already know that this a is not going to do anything, but my 8 will. That's actually, if you think about it, that's 2. What is 2 times 2 times 2? Think about 2 times 2 times 2. A lot of people forget this one. And you will see that, yes, it's 8. So 2 cubed is equal to 8. So the cube root of 8 is 2. Don't forget I still have that a that was there. And, yep, that was cube root. And then the next term that I have was the 4. Now you can see that everything is matching, and I can do my adding and subtracting. 2 plus 4 is 6, and then we have the cube root of a. Okay, so all my answers over to the right, problems to the left. All right, if you let me get ready, I'm going to set them up to learn how to multiply and divide. Okay, so next we're going to learn how to multiply and divide them. And here's your steps. This time it doesn't even matter if the inside matches. That's what's great about these. You just multiply. The only thing that you have to make sure of is that your index matches. So you can't multiply a square root and a cube root together. So as long as they match, you just multiply. You'll see here they did a 3 times 7 got 21. They did 5 times 6 got 30. X times x is x cubed, and then the y. And then from there, you simplify. So you do simplify them if possible. So some of these first problems that are taken from your textbook, we're going to do first, and then we'll try some with FOIL. All right, so let's start. Number 5. Number 5, I multiply what's inside. 5 times 10 is 50, and then I have x squared. Okay, that's going to simplify. How do you simplify 50 as a radical? Well, you do your factor tree. So I do my 50. I'm going to do 10 and 5. Let's see, 2 and 5. And I'm down to all of my factors that are prime in square roots, so I circle by pairs. So that means that it is, no, I need to continue my meeting. That means that I have 5 square root of 2. Okay, so I have my answer. I'm ready. So I have my x squared that I can pull out. So number 5. I have a 5 on the outside. My x squared, I take half of that and I have x. And then what I'm left with on the inside is radical 2. All right, number 6. If I multiply 8 times 50, 8 times 50, and I'm going to get 400. And then if I do a times a, I get a squared. Let me move my factor tree from before. Okay, so then I have to see if 400 will split. It probably will, but you might not realize that 400 is a perfect square. 400, square root of 400 is 20. So you basically have your answer already. Square root of 400 is 20, and the square root of a squared is already even, and I pull out 1, and I'm left with nothing on the inside. There's nothing left. Okay, so number 7. Let's see, multiply 3 times 12 is 36, and then I have an M, and then I have an N. Okay, so this one, just by looking at it, no factor trees involved, no reducing of the radicals, because 36, the square root of 36 is 6, and my M and N are in the first power. So I can't do anything with that. So I'm left with 6 onto the square root of M N. Okay, number 8. Let's see, 21 times 7. And yes, I have my calculator right here beside me. So I can get these numbers quickly. Let's see, 147. And then I have an R and I have a T. Okay, so 147. Let's see if 147 will go down. This one might be tough because you might not know. Let me check it on my calculator just to make sure that 147 is 49 times 3. Always check everything. You never know. I'm down to my factors, circle my pairs, and I am left with 7 onto the square root of 3. So I'm now ready for my answer. I have a 7 on the outside, I have a 3 on the inside, and I have an R in the T that's to the first power. So that stays on the inside. Okay, let me erase my factor tree here. And let's look at 13. Okay, so number 13. 12 times 15 is equal to 180. A cubed times a squared is equal to a to the 5th. And b to the 1st times b to the 5th is equal to b to the 6th. Okay, I'm going to have to split a 180. So I will draw my factor tree to figure out what that is. Let's see. Okay, down to prime. We'll do 2 times 9. And then that is 3 and 3. Okay, so I'm ready. I have a 2, I have a 2, I have a 3, and a 5. Circle my set, and I'm ready. So, 2 times 3 is 6. That's my sets of 2, and I'm left with a 5 on the inside. So here we know that we have a 6 on the outside, and we have the 5 on the inside. Don't forget what we learned in simplification. I'll write the first one out for you. Go down 1, so it will help you. And then from there, I'll write my answer. Okay, so number 13. I have a 6. Okay, A4 can pull out. That is A2. You know what? I didn't even do that right. Because the 6 was already positive, so there was no reason for that. Did any of y'all catch that? Okay, so the B6, half of that is B3. And then I see what I have left. So you don't get confused, cross off what you already used, and I'm left with a 5A on the inside. Okay, let me erase my factor tree so we can move on to another problem. Okay, number 14. Number 14. So we have 18 times 2, and that gives us 36. M to the 5th times M to the 1st is M6, and I am ready for my answer. Square root of 36 is 6, and then half of the M6 is M3. Nothing left on the inside. Okay, number 15. If I multiply my outside, I have 35x. On the inside, I have 6. 3 times 2 is 6. And then I have an x. And then I have a y squared. So from there, I have to see if anything will pull out. Square root of 6 won't happen. 2, there's no even power on the x. There is an even power on the y. So I can pull that out. So I have my 35x that was already there. I can pull out half of 2, which is y. That's this term. And I'm left with, on the inside, with 6x. Okay, number 16. 8 times 2 is 16. MT. If I go to my inside, I have 14 times 50. That gives me 700. And I have 2m. And I have 1m. Okay, so let's check that. M squared n 16 mt. Okay, so I have to square root my 700. I'm going to draw out my factor tree, and I'm going to get, let me change some colors down here. So this part of it right here will be 10 onto the square root of 7, m squared n. So from there, I can pull out. Don't forget this outside 10 has to multiply by the 16 that you already had to begin with. So on the outside, I have 160. If I pull out my m squared, I have 1m times the m that was there. so that gives me m squared. I still have a p, so I've taken care of the 700. I've taken care of that. So all I'm left with on the inside is an n. Okay, so next step is to see multiplication if it has to use FOIL. Okay, so here is a FOIL situation. You'll see that it's a binomial times a binomial. So I just do FOIL. 3 times 4 is 12. That's first. Outer, I have 4 onto the square root of 2. Inside, I have 3 onto the square root of 5. And then last, when I multiply that, 5 times 2 is 10. So from here, you just look at them and see, can anything be put together? Can anything be simplified so that it can be put together? None of these can. 2 is prime, 5 is prime, 10 is going to split to 5 times 2. Those are prime, so nothing can be simplified and pulled out. So basically, and you have to remember, you can't add them unless these are the same. So this is your final answer. This is as far as you can go on this one. I'll do one with subtraction. So let me see. First, 10. Outer, 2 on the square root of 7. Inner, 5 on the square root of 3. And then last, plus the square root of 21. And you might notice here that we're also to the same situation where these will not break down. Nothing will add together because they're not the same on the inside of the radical. So you now have your final answer. Okay, here's another one. I'm going to FOIL this one out. So if I multiply the beginning, I have radical 18. FOIL O outside. So that gives me a negative 9c. Inside, I have a negative 6c. Last, I have a positive 3c squared. Okay, this one can break down a little bit. So I'm going to simplify every one of them and then see, if anything can be put together. So 18 is 3 square root of 2. 9c comes out as a 3 radical c. This is a 6c because that will not come down. And then here I have a c that will come out from my 2. And then I'm left with radical 3 on the inside. So look across. Look underneath your radicals to see if anything can go together. It can't. Nothing matches. So here you have your final answer. Don't forget, something could match. This was just an example where you needed to simplify some things first. Okay, if you see one like 31 or 32, just split it. That is 2 plus radical 5 times 2 plus radical 5. Okay, next we're going to do division. Step 1, separate the radicals. So do radical on the top, radical on the bottom, simplify if possible, and then we're going to multiply the numerator and the denominator by the radical factor of the denominator if we have one. This is called rationalizing the denominator because you cannot have a radical on the bottom. So there are some examples here. I pulled some over for you. So we'll start with number 45. It told me to split them because we might get lucky and not even have a radical on the bottom. So I'm going to split this. This is x squared onto 7x, and then on the bottom I have 5 onto x. Okay, we cannot have a radical in the bottom. So I am going to multiply the top and the bottom by that radical sign, and you'll see what will happen, because if I do that, I have my x squared still out there, but on the inside I have 7x squared, and then on the bottom I have 5 onto x squared. And you'll see what happens here. I'm going to keep simplifying. This x squared will simplify, so now I have x cubed on the top. Don't forget, half of x is 1, so I pulled out 1x and multiplied it by this. That's where I got the x3. And I'm left with radical 7 there. On the bottom, I have a 5. X squared will pull out. That is an x. And we're good now because we do not have a radical on the bottom. You can't have a radical on the bottom. Cannot have a radical on the bottom. Okay, so let's go to number 46. Don't forget, if you are missing your screenshot, this is being recorded, so all you have to do is pause it and go back. Okay, so number 46. Split them. Simplify. Nothing on top. On the bottom, yes. Square root of 4 is 2. That splits into a squared times a. Half of 2 is 1. And left with an a on the inside. I multiply by whatever is in the radical on top and bottom. So that leaves me on the top with 3a squared. On the bottom, I have 2a onto a squared. I can simplify a little bit. This a squared can be pulled out as 1a onto 3. This a squared can be pulled out, but when I multiply that a times that a, I'm left with 2a squared. Okay, now, whatever's on the outside is considered to be fair game. You can't touch what's on the radical. We've already done that. But you can see here that you do have some simplification that you can do with these a's. So if you remember your exponent rule, this final answer would be radical 3 over 2a. Oh, that box was not good. Okay, so number 48. Number 48. Split it. And then simplify. So I'm going to have m cubed. That came from my m6. 6m here. 75 turns into 5 radical 3. That turns into an m squared, so that's 1 on the outside, and my n squared pulls out to 1 on the outside. Okay, same problem. I cannot have a radical on the bottom. So I have to multiply top and bottom by what is in the radical. So I now have m cubed over 18 m squared over 5m n 9m squared. You can see here there is some simplification that can happen. The 18 is going to split. The m squared is going to split. The 9 is 3. This m squared is going to split. And you will be left with 3. I do have a 2 that's left on the inside. I pull this out, times that, I have m to the 4th. And then the 3 radical 2 is what split the 18. And then that 3 on the bottom, I have a 15. Split that, I have an m squared. And then the n is still by itself. Okay, watch your simplification. Simplification can happen again. You cannot touch what's in the radical, but you can touch what's on the outside. So 3 over 5 is 1/5. And then m to the 4th over m squared is m squared. And then I am here. And honestly, you don't even write the 1. So here is your final answer. Okay, next we have this issue where we're dividing, and in your denominator you have 2 terms, like you have a binomial. You'll see that 72 through 76, you do have a binomial in your denominator. So what you're going to have to do is multiply the numerator and the denominator by the conjugate of the denominator. So what is the conjugate? Conjugate is kind of the opposite. So if I had a plus 7, you can change, the conjugate would be a minus 7. So you're basically changing that middle term for your conjugate. And then, of course, at the end, you simplify if possible. So we're going to work one together. So I'm going to multiply by the conjugate. So top and bottom. So my conjugate is going to be 7 plus 5 onto the square root of 3. And you remember what I just told you. All I did was change the sign. Okay, so now I have to do this across. This is FOIL. This is FOIL all the way across. So I'll start my FOIL here first. Outer, inner, last, 15. Okay, bottom, first, outer, okay, inner, and last, square root of 9. Okay, so then I start simplifying. I look at the top. I don't see anything that can simplify. I can't add anything together because my radicals don't match. You have 3, 5, 15. That won't match. 15 will not go down. So I'm going to simplify the bottom. So technically, I could write this. It will not simplify. And now I'm going to start working on my bottom. You'll notice if I combine like terms, these are opposites, so they're gone. So now I'm just left with 49 minus 25 square root of 9. Okay, well, square root of 9 is 3. So pull out that 3, and you are now left with 49 minus 25 times 3, which is 75. And 49 minus 75 is negative 26. So I guess this whole problem would be negative, but you'll notice by multiplying by the conjugate, it's going to cause every bit of this to just, all the radicals at the bottom will fall off. If you do this and some things will simplify, then yes, of course, you need to simplify. Okay, so that gets you through simplifying with letters, adding, subtracting, multiplying, and dividing. Hope this helps.